All right, beautiful people. So today we're talking about what the special qualities are for equilateral and isosceles triangles. So let's start with isosceles triangles. Oh my gosh, come on, Miss Miller. Isosceles triangles. Okay, and isosceles triangles, remember, as a little reminder, are the ones that have two equal sides. Okay, so let's draw a diagram, and we're gonna just label it. So I know that these two things that are equivalent, they're called legs. These are the legs of an isosceles triangle. And then the side that is not equal is called the base. Okay, so the legs are those sides that are equal. The base is the other side. And then up at the top, this is called the vertex angle or the vertex. Okay. And then down here at the bottom, these two angles are called the base angles because they're attached to the base. Okay. Simple enough. So now we know what each of these angles are called. So I've got legs, I've got the base, I've got base angles, I've got the vertex angle. Okay. So isosceles triangles hold a few special properties. So there's actually a theorem called the base angles theorem. And I usually abbreviate it to BAT, B-A-T. So I'll probably use that later on. But I'm going to write down the base angles theorem. Okay, the base angles theorem says that if two sides of a triangle are congruent, then the angles opposite them are congruent. So for example, actually I'm going to use green. If I have a triangle, and I know that these two sides are congruent, then the opposite angles are congruent. So the opposite to this leg over here is this angle, and the opposite to this leg over here is this angle. So those two angles are congruent. So this is actually the base angles of an isosceles triangle are congruent. Okay. So the base angles theorem says that the base angles of an isosceles triangle are congruent. Cool. So then there's also what's called the converse. And the converse just basically says the opposite, and it just goes backwards, okay? And I'm going to write converse BAT, base angles theorem. And that is, it just goes backwards. So it says if two angles of a triangle are congruent, then the sides opposite them are congruent. So again, I'll draw a little example. If I have these two angles are congruent, then that means that their opposite sides are congruent. So the opposite side to this angle is this one, and the opposite side to this angle is this one. Basically, if the base angles, or if two angles are congruent, then you have an isosceles triangle. Okay, cool. So that's something that we know about isosceles triangles. I'm going to start a new page to tell you what we know about equilateral and equiangular triangles. Okay, so the first corollary is if a triangle is an equilateral triangle, then it's an equiangular triangle. So just for reference, over here in the corner, I'm going to recall equilateral. Equilateral means that it has the same or congruent sides. And equiangular means that it has the same or congruent angles. Okay, and you can get that from the second part of that, angular or lateral. Lateral means sides or legs. And then this basically just says if I have a triangle where all three sides are the same, then guess what? All three angles are also the same. Okay, and then this also has a converse. So converse to the corollary. And that is if a triangle is equiangular, then it's equilateral. So again, quick example. I know that all three of these angles are the same. That means that all three of the sides are also the same. Okay, so those are just statements about equilateral, equiangular, and isosceles triangles. The next video is going to be why is this important.